So let's take a look at Sapling problems 7 through 13. The first few problems that you have in here are just asking you to identify functional groups. And this should be pretty easy for you, especially if you are using those 3 tables in chapter 11 that have the functional groups named in them. So all that you have to do is look at the yellow box with the functional group in it and match it up to the functional group that you see in one of those 3 tables in your textbook, and then just go with the name. The names might be a tiny bit different because Sapling is not written by the same people that write your textbook. So notice here that aromatic, your book calls it aromatic compound. Sapling is calling it benzene aromatic. It's the same thing. Also, there's a little bit of discrepancy here. Hydroxyl group, alcohol, our book calls it alcohol. Carboxylic acid, which Sapling calls carboxyl group. So don't be thrown by any of these names in parentheses. And you've got several of these problems where it's asking you to just identify the functional group. The other questions that you have on here are asking you to look at multiple structures of molecules and compare them and determine if there is a relationship between the 2 or 3 or 4, in this case 7 molecules. This one's a little trickier, so let's do part of this one together. So for this one, we're given this molecule up at the top of the page, and we're being asked which of these molecules down here, and there's 6 of them total, which of these are identical or represent the same compound as the one up here. Probably the easiest way to do this is to look at the molecule in the same way that you would look at it if you were going to write its condensed structure. If we were going to write its condensed structure, we would look at the molecule like this. We would look at it as a CH3 followed by a CH2, followed by another CH2, and another CH2, and another CH2, and then finally a CH3. So we could write that out as, I'm going to use the parentheses, CH3, parentheses, CH2, 4 of them, CH3. Now remember, it does not matter what kind of shape we use when we draw these molecules. It doesn't mean anything. If we have a molecule that has this same pattern of connectivity, regardless of its shape, it's going to be an identical molecule. So let's look at the first option that we have. In this molecule, if we start at the bottom here, we have a CH3 followed by a CH2. And yeah, it's weird, but it is a CH2, followed by another CH2, followed by another CH2, followed by another, and then a CH3. A CH3 with 1, 2, 3, 4 CH2s and another CH3. These are the same. This molecule is the same as the one that we started with. Let's try that again with the next one. We're going to pick, you can pick any end of the carbon chain. You could start down here, you could start up here. I always kind of like to go left to right. So this one has got a CH3 followed by a CH2. Doesn't matter how those hydrogens are pointing. Next is a CH3, or sorry, that's a CH2, followed by another CH2, and then there's another CH2. Here's one more CH2. Uh-oh, that was too many. 1, 2, 3, 4, 5. That's too many CH2s. Our original molecule only has 4 CH2s. This one has 5 CH2s. This one's not the same. It's different. It's got too many CH2 groups. So that's the strategy that you're going to take with this. And with this particular problem, there's going to be more than one right answer. Like maybe that's another right answer. So make sure you look at all of them and select all of the ones that are identical. This question, question 12, is really similar. It's just not as big. So it's giving you pairs of molecules. So we're looking for starters. We're looking at just these 2 molecules A. And it wants to know what the relationship is between these 2 molecules. Are they the same compound? Are they structural isomers? And if you look up here, structural isomers, it says also called constitutional isomers. That's what we call them. So are they the same? Are they constitutional isomers? Or are they just two totally different things? So again, it might be easiest to approach this the way you would tackle it if you were trying to write its condensed formula. So let's see if we can figure that out. It's a CH3 followed by a CH that has another CH3 hanging off the top, followed by a CH2 and a CH3. Let's see if we can match that pattern. A CH3 followed by a CH that's got another CH3 hanging off of it, followed by a CH2, CH3. So these guys are the same. They're not pointed in the same direction. This one has its extra CH3 on the left-hand side, and this one has it on the right-hand side. But again, direction doesn't matter here. It doesn't make any difference. If you can find the pattern, find the same arrangement of atoms, then they're the same molecule. And then last, we've got one more problem that's similar. Again, you're going to be looking at pairs of molecules, and it's asking you what the relationship is between these two molecules. So probably, again, let's just keep doing what's working. Let's go with the way that we would write out a condensed structure. This is a CH3 followed by a CH2, another CH2, and a CH3. What do we have over here? We have a CH3 followed by a CH. So these molecules are not the same. Not the same. So then we have to decide, are they constitutional? Or are they just totally different? If they're not the same, they're either constitutional isomers or they're different. So the way that we distinguish, the way that we determine, remember, constitutional isomers are going to have the same formula, the same number of carbon atoms, the same number of hydrogen atoms. Different molecules are just going to have different formulas. So now we have to ask ourselves, so what are these guys?